Okay, there are a few people. Good. And how many of you were able to perform that recovery on the first try completely correctly? Okay, I see some fans. That's very good. But that's, well, that's definitely not everyone, because as you can see, keeping data safe at scale isn't easy. So today's topic is data integrity, which is one of the aspects of keeping data safe. And this is one of the most terrifying topics I can think of. Well, just because it's scary, but just because it's terrifying, we cannot just ignore it or pretend that it doesn't exist and hope that everything will work out once we have to recover our data from backups. It is definitely a time for a plan. So hope is not a strategy. This is one of the main mottos. And this applies to various services. And this applies to the data that is backing those services as well. So many internet services, many corporate services, many of them implicitly rely on integrity of this data. So, well, we rely more and more on this data. So there is more and more data every day, and it's not only the number of bytes overall that there are in the world, it's also about the growing numbers of different platforms and different uses of this data. So I would say that it's more and more important to preserve that information. And the way that this information is preserved, it also has to change with the data. So for example, there could be challenges of scale. So imagine that, for example, like 10 years ago, you could have a service that contained all its data only in some SQL database. Nowadays, people use various stores for various things, right? So for example, for monitoring, we can use some time series store. For some very important data, we will probably use some ACID storage, like a SQL DB. But for example, if we care about the volume of the data, we'll probably, and availability of the data, we'll probably use some base storage, like a blob storage. So if you have multiple services like this, and they have references one to another, how do you make sure that you maintain the referential integrity? Another example, let's say you start up a service several years ago, and this service stores some important data. And it used to store about like a terabyte of data. But nowadays, the service has grown to a petabyte scale, or maybe if you have a really large service, maybe you have an exabyte of data. Maybe you even have a backup mechanism, maybe even you have a backup plan, but will the same thing work? The thing that worked at the terabyte scale, will it work at a larger scale? So there are many questions like this that can be asked. And they all concern data preservation. But what is data preservation really? I think we can split it into several aspects. So there are three main aspects of data preservation. So, well, the first one is durability. So the data has to be durable to be used, right? The next aspect is data integrity. So when we say data integrity, this means that the data is exactly what was written. Any deletions, any unwanted deletions, any corruptions of the data means that we don't have data integrity. There is also data availability. So if the data can be accessed, if we can serve from a database, well, that's really important. Many services care about data availability. Many customers care about data availability. Imagine what happens when, for example, YouTube is down for 5 minutes. There is like a tragedy everywhere in the world because people can watch their videos, right? So availability frequently translates into the reputation of the service. But I would say that we should put more focus on data integrity, because if you don't have data integrity, if you can allow for data to be garbled, to be to have some missing bits, then probably data availability is like on the second place. Why would you care about making data available when it's not useful for anyone? So of course this matters, and it depends on the type of data. Let's take a look at integrity and availability and compare them with each other. So let's say that you have a target to achieve, an SLO of 4.9. So this is 99.99% of availability of your service. If you think about downtime that you're allowed to have during a year, it will be almost an hour of downtime. This is actually a pretty strict availability requirement. I mean, only at an hour of downtime. Many services don't provide that availability, and many customers don't need such availability. However, well, sometimes there are products that need such high availability. And if they don't meet their objective, well, sometimes some customers get annoyed, maybe some customers change the service to another service, but in general, the life goes on, right? Generally, the users recover from the downtime. However, if you have a similar target for your data integrity, this means that for every 2 GB file, you can afford to lose 200-ish kilobytes of data. It could be corrupted or missing. So, of course, for some applications, you cannot afford this, right? If you have, for example, an executable, even if one bit is off, it could be useless. If an important legal document has lost several pages, a database is corrupt, some video metadata is garbled, then you can't really recover from this. Unless maybe you found a solution. One of the most common solutions to this problem, that sometimes data gets corrupted or lost, is data replication, right? So you could say, my data is replicated, my job is done, right? Oh, this is wonderful, and this helps with many problems, but it unfortunately doesn't allow to ensure high data integrity, high data preservation. So having multiple replicas of your data is definitely not like having backups that you can restore from. So the main difference between just replicating your data and having separate backups is that if you, for example, have some unintended deletions or corruptions spreading across your replicated data, it will spread quickly. I mean, you wrote your replicated data store. You set up it in a way that you wanted it to replicate data fast, right? So every corrupted bit of data, it will spread like a virus. So another problem with replication, why it doesn't help to ensure data integrity, is that everything is running on the same software stack. Maybe it's even running on the same storage devices. So imagine, even if your software is okay, maybe you are using some hard drives that have a firmware that have a known 0-day, and you are still prone to those vulnerabilities. Of course, you have to take this with a grain of salt, because it's not as likely as, for example, a problem when a user of your service, if you provide a storage service for some users and you allow users to delete data without having like this soft delete feature, that's definitely a more realistic problem than 0 days in their drive firmware. But still, this is like the same class of problems. Also, even if you replicate your data, even if you have backups, if you keep everything at the same site, so in the same data center, maybe even in the same town or in the same country, then you still are risking that this data could be gone easily. Imagine the great library of Alexandria. I mean, I'm sure that they had multiple copies of those scripts on papyrus in this library, but once the whole library burned down to the ground, well, there are no copies anymore. So, I mentioned that backups are useful, right? So we need backups. We need backup plan. Really, do we? We don't need a backup plan. What we need is a restore plan. So the backups are part of the restore story, but you shouldn't be really focusing on the backups, but on the restores themselves. And this is because if you think about restores first, you're suddenly asking a lot more questions than if you think about backups themselves only. So if you think about restores, you suddenly care about questions like, are you sure you backed up the right data? How will you find that backup when it's time to restore it? Maybe you store this information in some other database that maybe doesn't have backups. Maybe there is a, as I mentioned, maybe there is a document that tells you what to do. How can you recover the data back into the service? So it's easy to say, okay, I did a backup, I'm done. But did you actually try to mount this backup? Did you actually try to merge this with existing data? This is a really useful exercise to try out from time to time. How long will the recovery take? This is also an important thing, because if you have backups but you cannot restore from them quickly, maybe you could go out of business because of this. So, for example, if you're keeping plenty of backups of your data, but you have to restore everything to every bit of your backup to get to the data that you're interested to, it will take probably a long time, who knows, hours, days, months, depending on how much data you have. So how much extra storage and processing will you need? That's also something to consider. And are you sure that the recovery process is not going to interfere with the service that is running? I guess you wouldn't like to turn down your service just because you need to restore some data from a backup, right? So as you can see, this restore-centric approach, this is much more useful, much more business-centric way of thinking about this. So you could say that, yeah, I guess I could take a look sometime later, maybe never, or maybe someone in my company will take a look instead of me. But actually, you need these answers now. Or a couple of days after the push for the new feature, when you realize it's been accidentally deleting chunks of critical data, and you need this data now. Then, well, I guess you could learn your answers then. Or maybe you can learn it before it happens, right? And by the way, if it's like during the weekend and the only person who understood the backups left the company a few months ago, then, well, it's not a good situation. I hope you think this sounds scary. I certainly do. So what can I do to make it better? What can I do to be prepared? So consider all of your recovery options. It doesn't have to be backups. As I told you before, backups are only part of the story. Actually, the restores are the goal, and the backups are frequently the tax that we pay to achieve this restorability. If there are alternate sources of funding, I guess you could use them as well. So for example, if your data could be reconstructed from some other data store, some canonical data, maybe that's a way to solve this problem. On the other hand, maybe reconstruction from this canonical source, maybe it takes too long, so you still need backups. If you have stateless services, that's perfect. You reach the pinnacle of data integrity. There's no data to be preserved, so you don't have to care about backups, right? Or maybe some other kind of magic that you can think about. I mean, there is never a silver bullet. Maybe you can outsource this to some other service that can guarantee you some level of data integrity. That's also an option. So you can also leverage your service structure. If you store your data in a replicated way or in a sharded way, or both of these strategies applied at once, This is useful for making backups and recovering from backups. So, for example, if your data is redundant, if it's replicated across different places, different clusters, you can take backups from different locations. And also, it improves the reliability of taking backups because, if you hard code that you're always taking backups from this single instance, if this instance is down, then you are not taking any backups. So making it work with any replica, it increases reliability and also allows you to shift the traffic from one instance to another. It also helps with recovery. So for example, if you have your data sharded, let's say you have your data in 100 shards, then if you take backup for every shard separately, then it's easier to achieve a situation that's, well, it's harder to have a situation when a single shard is preventing you from taking a backup of the whole data. So imagine, like, if you have a problem with your data, it cannot be backed up. If you have this 100 shard situation, then you'll have maybe one shard that is not backed up, but you still have 99 shards that have backups. That's a better situation than having one large backup that's not working, right? So sharded backups are more manageable. Of course, there is an increased cost in having like 100 backups. So and be aware that if you're sharding your backups, for every dimension of sharding, you have to figure out how to maintain this data continuity when you recover. Because, for example, if you have a backup from several days ago of one shard, and you try to combine it with data from the other shards that are fresh, it could be problematic. I mean, this is strictly specific to your data store, right? This is strictly specific to your business logic, but you should have a way to merge this data that's coming from a backup with live data. And you should know how to perform a selective recovery. So one way of doing a selective recovery, as I mentioned before, if your data is already sharded, then restoring 1/100th of your whole data, it's probably faster, easier, cheaper than restoring all of it. And also, if you have, you can even go further with this approach. You could have backups implemented in such a way that you can select particular rows from a database, particular objects that need to be restored. And this is useful if it comes to the costs, but it also is useful if you want to prioritize, if you want to recover some things faster than others, certainly a possibility. Yes, so another important thing is to practice. So my prediction, well, the prediction of these slides is that your restore plan will not work the first time you try it. This shouldn't be a surprise, but it will probably be a surprise the way it breaks. You could say, yes, but this whole backup and restore, this is so time-consuming, right? Of course it is. So you can do this manually, but should you do this manually? So this way we arrive at the next suggestion: automate. Automate everything. If you can automate it, you should. Automation can serve as a documentation. Automation can be a way to teach new people in the team how backups work. You don't need to relearn the process each time. I mean, it doesn't have to be perfect. Even like a half of automated way of backing up things and restoring them is much better than no automation at all. And you don't need to decipher the notes written by someone else, so you don't need to scramble for answers, call people who are no longer working at the company. You can avoid all this. So, well, if you are at this point, nice work. You planned, you automated, you conquered this, right? So now you can sit back, relax, and just stop worrying. Well, this of course this doesn't end because your service is evolving, so you still need to test early and test often. If you have automation, why not run it continuously? Why not run it frequently so that you are sure that you can restore your data anytime you want? Sometimes it could break, right? Sometimes with some changes in your code, your backup and restore code could break, and that could also be an important indication that something has to be rolled back, something has to be done about the current state of the deployment or of the code. So there will be new features, there will be schema changes in your database. You will migrate from one platform to another, right? So you will increase the scale, and all these things can be spotted much easier if you have automated way of recovering from your backups. So test often, detect early, adapt quickly. I guess this has a lot of connection with the previous talk about monitoring to automate everything. So, well, this presentation is going to be a little shorter than other ones, but that's a summary of the slides. So even small data loss can contribute to serious consequences, financial consequences. Availability is important and is frequently driving all these objectives, all these promises that we give to customers, but it's only as good as the integrity of the data. So plan, practice, automate, test, and most importantly, avoid horror, panic, and tragedy. That's all about it, because it's the worst thing to do, to panic when you have to recover some important data. So if you'd like to read more about, if you'd like to learn more about data integrity, there is an excellent chapter in the SRE book. I can definitely recommend it. And that's the end of my presentation.